Okay, guys, I'm so sorry. I thought I had enough battery to last that whole thing. We're literally almost done. So this just cut off the first part in a really awkward place. But let me go back to this one. So we have b squared. If you wrote b minus 5, and we multiply this out, we have b squared minus 5b minus 5b, which is minus 10b, and then negative 5 times negative 5 is plus 25. So we get that positive 25 at the end, but we still have a b value in the middle, so that's not correct either. So you have to be on the lookout because I'm sorry, but I will trick you with this again, where we have a squared value and a squared value, but instead of a negative sign meaning difference of squares, we have a positive sign meaning not difference of squares, meaning we have a prime. Okay? And here are our last two right here. Okay, and literally that was the end of this one. Okay, so let's move on to the next section here. Page 112. On page 112, we're going to start by factoring using the greatest common factor. We're going to go ahead and skip that entry task part up at the top and go straight into factoring with greatest common factor. Now, anytime that we're factoring with the greatest common factor, we're looking at all of the terms that are in the polynomial, and we're trying to factor out the largest factor that we can. So that means the largest coefficient and the largest variable to the highest degree that we can factor out of each part, okay? So if we look at this, this first 2x plus 10, okay, now I see that x is only in the first term here, so I know I'm not going to be able to factor out an x, okay? But I'm looking at my 2 and my 10, and I know that they both have a factor of 2. So I can factor out a 2, and I'm left with x plus 5, okay? Now if I check this, I can check this by finding the product. 2 times x is 2x, 2 times 5 is plus 10, okay? For the next one, again, there's only an x in the first one. I look at my 3 and my 21, and I know that they have a common factor of 3, and I have x plus 7, okay? So when we're factoring it out, we pull it out to the front, factor it out to the front, and then you divide each part by whatever you factored out. All right, so let's look at this one. Now, in this case, I see that my coefficients 8 and 6 have a common factor of 2, okay? So I have a common factor of 2 for my coefficient. Also, I notice that I have an x squared and I have x, okay? So if I have x times x, and I just have x over here, both of these have at least one x. So I know that I can factor out an x, okay? So what I'm left with here, if I factor 2 out of here, 8 divided by 2, I have 4. X, I factored this x out front, so I have 1x left. Okay, this is a negative, so minus 3, and I already factored that x out, so that's all I have left. If I'm unsure, I can always multiply it. 2x times 4x gives me 8x squared. 2x times negative 3 is negative 6x. Okay, and that matches up here, so we're good. Okay, those two match. All right, next one. 6 and 12. Okay, I see right away that both of these have a factor of 6. Okay, this has an x to the third, this has x squared, so they both have at least 2 x's. So I'm going to go x squared. Okay, then what I'm left with here, I factored the 6, and I factored out 2 of the x's, so I have x plus 2. Okay, that's greatest common factor. Okay. Go ahead and take a second to do these first two here. Okay, I'll go ahead and write the solutions down. Oh, you can pause the video, of course. Okay. Okay, now this one looks quite messy. Okay. Here we have a polynomial in two variables. We have the variables x and y. but we still want to think about it the same way. We just have to factor out the largest coefficient that they share and the largest variable raised to the largest degree. Okay, so I'm looking at 12, 6, and 15, and I know that all of them have a factor of 3. This is 3 times 4, this is 3 times 2, this is 3 times 5. Okay, so that means that I can factor this 3 out of each of these. Okay, now let's look at the x's and the y's. Okay, this one has 4 x's, this one has 2, and this one has 1. So they all have at least 1 x. Okay. Okay, so here I have y squared, y to the third, and y squared. All of them have at least y squared. Okay, now I need to look at what I have left. Here I have left the 4. And I took 1 x out, so I have x to the third and y squared. I took both of those out, so I don't have any y's left there. Okay, now this one right here. This is a subtract minus, I have my 2 left. Okay, so I took out 1x, and I had x squared, so that means I have 1x left. I also factored out the y squared, which means I have 1y left here. Okay. Now I have a plus 5 is my factor left there. I factored out an x, and I factored out a y squared, so that's it right there. And that is the greatest common factor. Okay, go ahead and try the last one. Pause the video, and you can start it back up. Okay, so you should have factored this one like this. Now, anytime that we have a polynomial like this left inside the parentheses, we always want to check to see if we can factor any further, okay? Anytime that you're factoring, you always want to factor completely. So if I am looking at this and I'm thinking about what I know about factoring the easy way, I'm looking for a product of 2 and a sum of -5. Now, product of 2, I can only get a product of 2 by multiplying a whole number wise, by multiplying 2 and 1. So if I look at my sum of -5, there's no way that I can get to -5, a sum of -5 with a 2 and a 1. So this is my final answer there. Okay? All right. We are cruising. Okay, so take a look at this section right here. This says factor completely. Okay? Now, when it says factor completely, that means that after you factor it the first time, because you notice that you'll be able to use greatest common factor for all of these, after you factor it the first time, you have to check to see if you can factor again. Okay? In addition, when you're factoring, you always want to make sure that your polynomial is written correctly, meaning that you have the largest degree first, and your terms will count down degrees. Okay, so we have x to the third and then x. Over here we have x, x to the third, x squared. So before we factor this one, we want to rewrite it so that it says 4x cubed minus 24x squared plus 36. Okay, now you can factor it. All right. Okay, go ahead and take a second. I'm just going to set the phone down so I can write the solutions here for you. Pause the video, take a second, and solve each of these. Okay. Okay. Here there. Okay. All right. Now, if you're unsure about any of these, then just go ahead and send me an email and ask me the question. Okay, this one, there is a step that I didn't show here. So when you solve this, first of all, you factored out the 2. And so you have x squared plus 7x plus 12. And the same thing with this one. There was a step in between here before we got to this part right here. Okay, and it's where you factor out your greatest common factor right before you do this part. Okay. All right. So factoring by grouping. Now, when we're looking at factoring by grouping, anytime that you see a polynomial that has 4 terms, you know you're going to use factoring by grouping. Okay. So if there's 4 terms, you will use factoring by grouping. All right. Now, when we factor with grouping, here's what we have. We have A, let me write this, plus B plus C plus D. Okay. Right? Essentially, you have 4 terms. Okay. You want to group together the first 2 and group together the second 2. Now, when you group together the first 2, let's go X, 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 X. Okay. When you group together the first 2, you look at these first 2 here, and you're going to take out the greatest common factor. Okay. So here we have X as our greatest common factor. Okay. So I'm going to change this one right here, so it makes a little bit more sense as we're working. Okay, so I factored out my greatest common factor of X, and I have left A plus B. Okay, now I look over here at my second group. I want to find the greatest common factor here. Okay, that's plus Y. And what we have left is C plus D. Okay, so when we're factoring out each of these parts, you want to factor out your greatest common factor, and you want to end up with something inside of the parentheses. Now, actually, in all reality, let me rewrite this so that I can talk about it a different way. Okay, sorry, I just rewrote this so we could talk about it a little bit differently. So here we factored out the X, and we're left with A plus B. Here we factored out the Y, and we're left with A plus B. Okay? Now, when we're writing down what our factors are, what our factors actually are X plus Y and A plus B. Okay, these are the 2 factors here. When we use grouping, what you have inside of these parentheses should always match. Okay? Because let's think about this. If we have these 2 binomials, essentially what you're doing is you're taking X and you're multiplying it by A plus B. Then you're taking Y and you're multiplying it by A plus B. That's what we see right here. That's this part. Okay? This is what your solution would be. This shows us a middle step. Okay? So when we factor it, then we know that X plus Y is one factor. And whatever you have in the parentheses, the A plus B, is the other factor. Okay? So let's give this a try. All right, here, remember we grouped together the first 2 and we grouped together the second 2. Okay, I want to take the greatest common factor out of this, and if I'm looking at the 10 and the 6, I see my greatest common factor is 2x squared. Okay, so I'm left with x minus 3. Oops, sorry, 5x minus 3. Okay, now over here, I'm looking, and if I'm looking at this, really the only thing that they have in common is plus 1, is a 1, okay? And then what I have left is 5x minus 3. And that seems to work because these 2 match, okay? So then I put my 2 binomials together here, 2x squared plus 1, 5x minus 3, okay? And these are the 2 factors for this polynomial. Okay. All right, let's take a look at the next one. Okay, over here, again, we're going to group our first 2, group the second 2. Now, when I group these two, I know that my greatest common factor between 9x cubed and 45x squared is going to be 9x squared. And what I'm left with is x plus 5. Okay. Now, this is the tricky part because I notice that there's two negatives over here. I also know that my target, essentially what I want to get in the parentheses, is x plus 5. Now, the only way to have a positive here and two negatives here is to have a negative 4 here. So if I factor out a negative 4, I'm left with x plus 5. Okay, now I can check this. Negative 4 times x is negative 4x. Negative 4 times 5 is negative 20. Okay, now I'm going to look at what my factors are. 9x squared minus 4 is one factor. X plus 5 is the other factor. Now, what we said earlier is that we always want to check to make sure that we've factored completely, okay? Now, x plus 5, that obviously looks like it's been factored completely. But my 9x minus 4, or my 9x squared minus 4, that reminds me of something. Difference of squares. Yes, difference of squares. So this is squared, and this is squared. There's a subtraction sign in the middle. So 3x plus 2, 3x minus 2, x plus 5. Okay, so this one factored out again to these two parts. This is left just the same right there. Okay, whoops. And that's my final answer. Okay. All right, we'll do one more together, and then I'm going to let you do the other three on your own. Okay? All right, this one right here. So I'm going to group these two and group these two. Here I have a greatest common factor of 2x squared. Okay, what I have left over, I have 3x minus 1. Okay. Now, greatest common factor here is a 7, so we have plus 7. 3x minus 1. If I check this, 7 times 3x is 21x. 7 times negative 1 is negative 7. Okay, we're good. Okay, so this is one factor here, 2x squared plus 7. And my other factor is this part here, and that is 3x minus 1. Okay? All right, go ahead and take a second to do the last three. I'm going to write the solutions down as you're working. Okay, so just hold on a second. Okay. Actually, I'll just go like this so you can see it. So go ahead and pause the video, work on these next three, okay? Then unpause the video and you can see each step, okay? Okay. Just one there. Okay. Now, I am realizing, okay, hi. I'm realizing that this has already been kind of a long lesson. So I think that this last section right here, factoring with a leading coefficient greater than 1, we're going to start there with tomorrow's lesson, okay? So tomorrow we'll start off with factoring with a leading coefficient greater than 1. And then after that, we're going to talk about the zero product property, okay? Now, zero product property is really important, and it's the next step as to why we're factoring in the first place, okay? So I hope that everyone had a great day. I am headed off to a costume contest tonight, and hopefully I will win because I'm going to be dressed as pumpkin pie again. So I will let you know tomorrow if I actually won the contest or not. So that's tonight at 9, and it's at the conference. So it should be pretty exciting. So on your exit card for today, please write down where I'm going tonight and what I hope to win, okay? I hope everyone has a happy Halloween. Please, please, please be safe tonight, okay? Make good choices, and I'll see you on here tomorrow. Okay, bye.